Hello everyone, this is Dr. Lennon, and I just wanted to walk you through a few more mixture style word problem examples. They come up a lot in practice. Again, remember the strategy is to name your variables, create a chart, and then usually you can get a couple of equations, one that you want to solve that has two variables, and then another where you want to replace one of those variables, make a substitution so you're just dealing with a linear equation in one variable. So in this problem, Rachel has $6.30 in nickels and quarters. The number of nickels is twice the number of quarters. How many coins of each type does she have? I think we had a similar problem in the last video, but we were dealing with pennies and quarters. So this time we have nickels and quarters. So again, we're going to let n equal the number of nickels. So again, that's just the number of the actual coins, not their value. And we'll let Q equal the number of quarters. Again, the number of quarters, not the value of those quarters. So we have two equations. We kind of have like one for the number of coins we have and then one for their value. So we know that the number of nickels is twice the number of quarters. So there are fewer quarters. So that means actually n is the same as 2 times Q. If you double the smaller number of coins, you get the larger number of coins. And then what's the value equation? Well, if you multiply the nickels by how many cents each coin is worth, so 0.05 times n plus 0.25 times Q, we get the total number of cents that they have in value, which is 630. Again, I'm using the unit as cents rather than dollars and cents. So then what we want to do is replace n by 2q, so we get 0.05 times 2q plus 0.25q, and that equals 630. So 0.05 times 2q is 0.1q, so 0.1q plus 0.25q is equal to 630. 0.1q and 0.25q are both like terms, so we can add their coefficients. So we end up with 0.35q. That equals 630. And we just want to, since we're multiplying q by 0.35, we divide by 0.35. And we end up with our number of quarters. So our total number of quarters comes out to oh, you know what? I made a little bit of an error here. I was using, so notice what mistake did I make? I made the mistake of using actually cents as my unit here, so or dollars as my unit, because if 5 cents is $0.05, so actually rather than being 630, I want 6.30. So 6.30, because I am using dollars as my unit, not cents. So you could do it the other way. So this is dollars. If I wanted to solve the same equation using cents, I would write it instead as 5n plus 25q equals 630. Both of them are going to come out to the same answer. So what is that answer? So you have to be really careful with those units, because if you're not paying attention like I was, you can kind of mess them up easy. So you get 18. If you do it over here, your equation would just end up as 35q equals 630, which would also give you 18 as your answer. So either way you do it, you're going to come out the same with 18 as your answer. And then the number of nickels was double the number of quarters. So n would be equal, the number of nickels would be 2 times 18, which is 36. So your answer for this problem would be 18 quarters and 36 nickels. That's the breakdown. Okay, so pretty straightforward. Again, pay attention to the units. Usually with these coin problems, we can kind of write down the two equations, and we don't need to get involved in a table. The next few, though, I typically like to use a table. So this next one, we're mixing two types of coffees to make a blend. So we kind of have the weight of the coffee and the cost of the coffee. So we'll have two equations there. So we have Kona and Maui beans. So let's let K be the weight of the Kona coffee used in the blend. And let's let M be the weight of the Maui used in the blend. I don't know how to spell Maui, apparently. Put too many I's there. So let me fix that. All right. So let's see. This one is pretty similar. So our weight equation would say, okay, if you take the amount of Kona used plus the amount of Maui used, that would be your total weight of 25 pounds in the blend. So this is your weight equation. And then you would have a cost equation. So the thing here is, what is our cost? Well, we know that the Kona is $15 per pound, so 15 times the number of pounds of Kona, 15K, plus 24, the cost per pound of your Maui, times M. That's going to give your total cost. Now the total cost, it says, is $17.70 per pound. Well, I would see a lot of students write equals 17.7 and stop. But that's a mistake. That would only be if you're using 1 pound. But we're not using 1 pound. We're using a total weight of 25 pounds. So this is your cost equation. So usually what we do in the weight equation is we want to solve for a particular letter. That's not going to matter. So let's just clean up the second equation first. 15K plus 24M. And we want to do 17.7 times 25. That is 442.5. So that's the total cost. It's some expensive coffee. So what we want to do is we want to either get rid of the K or get rid of the M in this 15K plus 24M equals 442.5. It doesn't really matter which one you solve for. Let's go ahead and just solve for K, let's say. So K is going to equal 25 minus M. You're just subtracting M on both sides. So what we do is we just take K and we replace it by 25 minus M in parentheses. So we have 15 times the quantity 25 minus M plus 24M equals 442.5. So this is by substituting (25 minus M for K). So to finish this equation, let's go ahead and distribute. So 15 times 25 and 15 times M to get rid of the parentheses. So that would be 375 minus 15M plus 24M equals 442.5. And then we can combine the minus 15M plus the 24M. So we have 375 plus 9M equals 442.5. So subtract 375. So we have 9M is equal to 67.5. And then we just want to divide by 9. So when you divide by 9, we end up with M is equal to 7.5. So how do we solve? Well, remember, if we go back up to the top, we have that K plus M equals 25. So we just plug this into that equation. So K plus M equals 25. So replace M by 7.5. And then subtract 7.5 on both sides. So we have K is equal to 17.5. So those are our two values. We're mixing 7.5 pounds of Maui coffee with 17.5 pounds of the Kona blend. We could plug that back into 15K plus 24M to see if that, so if we wanted to do a check, we could. What would the check be? We'd say, okay, 7.5 times the cost of the Maui, which is 24, plus 17.5 times the cost of the Kona, which is 15. We want to check, so plug that into your calculator. 7.5 times 24 plus 17.5 times 15, and we get 442.5. So that checks out. So we know our answer is correct. Okay, let's do one last example. So this is another one where we have Stephanie putting money in two different accounts. One that's a bit safer, that typically averages 2.1% interest, and one that's a little bit riskier, but she expects 6.5 interest. And if she wants to have an anticipated earnings of 5.4%, what is that going to be? So again, let's let A be the amount in the 2.1% account, and B be the amount invested in the 6.5% account. So again, we could make our chart if we want. Account, amount invested, the rate, and the total interest. So this is typically what we use in this. I mean, you could use it for any of the problems. This one seems to be the typical one. So we have the account A, B, and then the total. So we're saying A dollars is invested in account A, B dollars is invested in account B, and the total invested we know is $40,000, which would also have to be A plus B. So that is actually going to be our equation relating the two. So our equation relating the two is, we know A plus B equals 40,000. That's the total invested. What are the rates? We said, again, we want to do these as decimals, so 0.021 for account A and 0.065 for account B. And for the total, we're anticipating a 5.4%. So the total interest we get by just multiplying across the row. So we would have 0.021 times A and 0.065 times B. And then we know the total interest is that 0.054 times 40,000, which is 2160. So our total interest equation is 0.021 A plus 0.065 B. That equals the total of 2160 in interest. Again, for the top equation, we want to solve for one of the letters, so we can say A is 40,000 minus B. So let's replace A with that 40,000 minus B in parentheses. So 0.021 times 40,000 minus B equals 0.065 times B, and that is equal to 2160. I wrote an equals down where it should have been a plus, so let's adjust that and go ahead and distribute. So 0.021 times 40,000 is 840, so we get 840 minus 0.021 B plus 0.065 B equals 2160. So 840 plus 0.044 B, this is equal to 2160. And then we want to go ahead and subtract that 840. So we end up with 0.044b equals 1320. So we divide by 0.044, and we're going to get the amount in account B. So if we do 1320 divided by 0.044, what do we end up with? It comes out to 30,000. So account B is 30,000. And we know they total 40,000 together, so that makes account A $10,000. So she is investing $30,000 in that higher yield account of 6.5% and $10,000 in that lower yield account, the certificate of deposit at 2.1%. So that's the mixture. Again, we can do the check here. So how do we check that? Well, we just go back up and we say, okay, well, we're basically going to check it in the 0.021 equation. So if we do 0.021 times 10,000 plus 0.065 times 30,000, we want to put that in our calculator and see if that comes out to 2160. And in fact it does. So it comes out perfectly to 2160. So that's how we know that we answered the problem correctly. All right, so again, that's it. The homework has a couple mixture problems on it, so make sure to go ahead and do those. And if you have any questions, please let me know, and I will be sure to answer them in my next video. So this is Dr. Lennon signing off.